Hi, Engineer Lawal. Good evening. How are you today? Okay. You can put if you have any comments, you can leave it in the chat room. Hi, Victor. Good afternoon. Victor, can you pronounce your last name?
Good afternoon. 1 minute.
Let me see if I can permit you to talk. Yes, Victor, you have the ability to talk, and I'm trying to see if I can do the same for Engineer Lawal. We can Engineer Lawal didn't connect his speaker. Hi, John Saliu. Good afternoon. All right. Welcome to today's webinar. Today we're talking about RAG, and I would believe that for you to have shown interest in joining today's webinar, you have a fair idea of what RAG is. RAG is Retrieval-Augmented Generation, and we're going to have a wonderful time, I know, a time of great learning, a time of good experience. We're going to be talking about embeddings, semantic search. I actually really, really love semantic search. You would literally say why semantic search is bettering our life, different from keyword search, right? And we're talking about embedding, semantic search, and vector databases. These are interesting stuff. We're going to learn about vectors and what vectors are, what embeddings are, and thank you for joining the call. If you can speak, Victor, you have the floor. You have the mic. You should be able to unmute your mic. I'm unable to give Engineer Lawal, Abubakar, and John Saliu the chance to open their mic. Maybe they are not connected or they are not joining from a compatible device. But either way, it's good to have you in the room. And thank you for joining us today. Our guest speaker is here for us and with us, and we're pumped that you're here and you're not just here. You're here with you came early. You're punctual. Thank you so much. All right. So without further ado, I'm just going to get started with introducing us. Introducing who we are, what we do, and why we're doing what we do, really. And we'll just take it up from there. All right, my name is Oluwatayo Winkonle. I'm the founder and CEO here at Techlytics. And with me on the call is John Haze and Ian Oluwashomi. They are my colleagues here at Techlytics also. And they have decided to also come support your learning journey. All right, so thank you. I'm seeing your chat. But maybe shortly before we start, if you can also tell us where you're joining from, that would be helpful. For example, my name is Tayo. I'm the founder and CEO of Techlytics, and I'm joining from Lagos, Nigeria. That would also be helpful. So let's have it from our attendees. Can you please tell us where you're joining from? And if you can tell us what you do, it also helps guest speakers to familiarize themselves with the people on the call. All right. So if you can drop it in the chat room in this format or in this order. My name is, Victor. I'm joining from Benue State. I'm a data engineer, or I'm a data analyst, or I'm, whatever your job title is, or I'm an aspiring, So it will really, really be helpful to know where you're joining us from. All right. Right. Oh, John Saliu is joining from Calabar. Thank you so much. How is the weather there today? I hope it's harsh as it was in Lagos. I mean, the weather was quite harsh to me earlier today. I just couldn't cry. I had a very long run. I really needed to practice to do like a race practice for my half marathon. the race practice for the marathon that is coming on February 14th. So I did a half marathon earlier today. I ran in the sun, literally. So I hope Calabar is cool. Hi, Mohammed. Mohammed, good afternoon or good evening, wherever you're joining us. We're just about starting, and thank you for joining us. Mohammed is joining. Mohammed, rather, he's joining from Abuja. Thank you for joining us. John is joining from Calabar. All right. I just also wanted to mention to us as well on this call, we also have some people join us on YouTube. All right. So as we are having it live there, some people are also binging on this webinar on YouTube. And thank you everyone for joining so early. And we're going to have a good time today. Today we're talking about retrieval-augmented generation, embeddings, semantic. We're talking about embedding, semantic search, and vector databases. All right, so let's get to it. And please let me know once you can see my screen. Let me know once you can see my screen. It could be a thumbs up or any reaction you are able to pull, just to let me know that you can see my screen. Yeah, no, can you see my screen? Okay, thank you, John, and thank you, the person that gave me the thumbs up. Okay, so welcome to Techlytics. What we're doing currently at Techlytics is to build Africa's AI-ready workforce through practical hands-on technical education. We cannot afford to be left behind in this emerging industry, right? For the better part of Techlytics, we've always been known as the company that specializes in data training and artificial intelligence. So we're staying through to that. We're staying through to that, and we're just continuing what we started. That's why we're continuing with. That's why we're continuing, or we're going deeper. That's why we're going deeper with artificial intelligence training. Somebody's mic is on, and I would need that person to mute their mic, or I come mute them, and that person is John. Okay. Yanolua, please help me mute John from your hand. Thank you. All right. Okay, so I'm just going to do a brief introduction of who we are. Techlytics is a hands-on technical education program built for Africa. You would agree with me that while, yes, there are many problems plaguing the world in the tech field, or plaguing so many societies when it comes to data and artificial intelligence, we also have our own unique problems here in Africa. And what we do right now is that we teach data analytics and artificial intelligence, not in theory, but through practical real-world application that addresses the unique challenges and opportunities on the continent. Our approach is rooted in practical labs, hands-on labs, or hands-on experience, and it is also built to suit, or is designed specifically for our environment, our realities, our culture, our infrastructure, and our ambition. What problem are we solving? 3 problems majorly, high level. We're solving the talent gap problem, the infrastructure challenge, and education disconnect. How are we doing this? For the talent gap, we know as of today that we have a lot of people who are undergraduates or people who are graduating out of, formal institutions. However, we have a massive shortage of AI-ready or data-ready professionals. So when we talk about digital transformations, we're still lagging behind, and that's why even the workforce continually submit their employees for upskilling all year round. So there is a big talent gap there. We are also solving for infrastructure challenge. That says a lot of companies have AI roadmap strategy and all of that, but they lack the people and systems to implement it effectively. We're also bridging the education disconnect. that is, tertiary institutions are producing graduates that are not equipped for the AI economy. So how are we solving it? We're doing it in three major ways. We're having corporate trainees, and basically what corporate training means is it involves enterprise AI labs and other data-related training programs to build internal AI capability. Now, we've seen a lot of enterprises that want to implement AI solutions. However, the bedrock of artificial intelligence itself is data. So if you've not gotten your data infrastructure internally right, if you've not gotten it right, you're still doing child's play when it comes to implementing AI solutions. So that is one thing we're doing. Also, we're also solving this by deploying university programs to prepare the next generation of talent so they are workforce AI ready. And basically, I must have said this. Why do we do this? We're providing contextual solutions to our own problems in Africa, right? We're basically focused on Africa. We are too much of a fragmented society or a fragmented economy not to have some form of contextual solutions that understand our major problems or our major infrastructure problems or our cultural problems, and provide solutions to those problems. So that is why we're doing this. We're breaking down the data silos and fragmentation, holding organizations back from realizing their full potential. These are the team of wonderful people here at Techlytics, and so I'm going to. This is not the slide I was supposed to be sharing. I'm going to quickly introduce our guest speaker. I apologize for that. I'm going to quickly introduce our guest speaker, who is Samuel. Samuel Theophilus is an AI product founder and AI engineer with over 6 years of experience building and deploying production-grade AI systems for enterprise use cases. He is the founder of CV Booster, an AI-powered career platform built on LLM workflows and knowledge graphs, and is widely recognized for translating complex AI concepts into practical business-focused solutions. Trust me, I have met with Samuel prior to this meeting or prior to this webinar, and you're in for a good time of learning. You're going to be imparted. And thank you again, Samuel, for honoring our invitation. So just before we begin, your questions are welcome. You can put your questions in the chat room, or you can raise your hand. We would give you the ability to unmute your mic. So please feel free to drop your questions in the chat room or in the Q&A section. The recording for this meeting or for this webinar is available. It's largely also streaming live on YouTube as we speak. And also you can stay connected with us. All right, so I'm going to hand over the mic now to Samuel. Hi, Samuel, mic check. Can you hear me?
Yes, I can hear you.
Good evening. Thank you again for joining us on this call. And I am going to mute my mic now while you take the lead. All right.
All right, thank you for having me. Let me share my screen. Can you see my screen?
Not yet.
Can you see my screen?
I can't see it yet, though.
Let me try to share.
Somebody said they can, or maybe it's me, or maybe it's my internet that is lagging. Can any other person confirm if they can see?
Okay, let me share it again because I disconnected. I stopped sharing.
Okay, I don't know. Can somebody else confirm if they can see Samuel's screen? Okay, it's coming up from my hand now. Yeah, I can see your screen now. Thank you, Samuel.
All right, so thank you for having me. So thank you everyone for joining as well. So today, just like it was shared, I will be talking about RAG, so retrieval augmented generation, and then of course, we're going over the basic components of a RAG solution, which is the embeddings, the system search, semantic search, and then the vector databases. To keep things simple, we'll be using the MongoDB Atlas as the vector database, and then also we will be working with Python. Just for context, for those of you joining, I hope that you all are in front of your screens and will be able to join us, because we'll have a demo. We won't just be theory, going over theory today. So let's get started. So yes, just like I was introduced earlier, I'm an AI engineer and I'm also a technical writer. So, and I also I worked on a number of projects. One, the most recent being CV Booster AI, which by its name tells you it's a resume optimizing solution. So you can connect with me on LinkedIn and we would go over the agenda. So yes, so what we'll be talking about today. So RAG, we'll be going over the basics. Before we dive into RAG, we'll go over the basics of how traditional LLMs work, and then we'll see the limitations of these LLMs and why RAG is even important in the first place. Why do we need a RAG solution? Why then? What does a RAG solution look like? What's the architecture? What's the pipeline looking like? And then also look at some practical use cases. Go over what the basics of an embedding, and then the vector database, and then of course we'll go into the hands-on, and hopefully we should be able to cover all this within the time we have. Then you have time for questions as well. So that being said, so what is a RAG? I think, all right, I think I messed up the order of my presentation. This is supposed to, so basically, why do we need how do traditional LLMs work? So we are familiar, for those of you who are joining, because I'm assuming that you have, not everyone here already has experience with, let's say, software development to, or rather we have different degrees. So I'll just go over the very basics. So LLMs, large language models, foundational models, like that's GPT-3, that's ChatGPT's or OpenAI's GPT-3, GPT 4.0, and then you have Claude AI, you have Gemini, you have DeepSeek, and all these large language models. So we understand, or since the breakthrough in LLMs, we have been able to see how powerful they are, and these are some of the very basic functionalities of LLMs, large language models, right? They generate text. So we have text, you can generate articles, generate essays, summaries, and the rest. Emails, process documents, and then you see they have the ability to also extract information. So LLMs have changed the way we analyze, let's say, things, solutions like, okay, extracting, even passing data from doing web scraping tasks, and then and so many other complex tasks that were initially difficult to be able to execute, being able to extract names, entities, identify locations, identify phone numbers in the large chunks of text, automate a lot of these processes. We are also able to debug on a level that has not been possible before, and also generate code, write code. We have vibe coding now, and then we have, of course, understanding documents, like I mentioned, summarization and the rest. So there's so many things that large language models are doing. So, but what are the limitations? Or rather, so before we even go to the limitations, how is a large language model developed? So basically, a large language model, if you look at why is let's say ChatGPT as intelligent as it is currently, is because this was trained from the basics of machine learning. You need data. A large language model is basically a very super intelligent autocomplete solution, but the reason why it's able to answer relevant questions is because the information that is trained on is very rich, and then it has been labeled, it has been annotated by experts. This makes it able to capture the knowledge, the expertise of a professional, whether it's a content writer, a doctor, or many of these things, because that's ingested a lot of a lot of content across the web, from web pages, from Wikipedia, or public forums, books, codes, and the rest. And so the reason why your LLM will be able to code is simply because it has ingested and understood how maybe code from GitHub repos and the rest. So this is the basics of how LLM works. It's trained on billions of data points of data, public data. And this highlights that in order to be able to train an LLM successfully, you have to first collect this data. That's crawled the web for data, and understanding the fact that data changes over time. So even Wikipedia, whether it is news or news outlets, CNN will have every day we have new articles published. Wikipedia has updates, changes to their sites every day. Last 4 years, the president of Nigeria was Buhari. This year, currently its president is Tinubu, and it's like that. So information changes. This means that LLM knowledge can get outdated, right? So it's very important. This context is what this will build context for why we need RAG. So given that the LLM knowledge can get limited to just public data, it means that there is a limitation. It can get outdated, and it can get some answers wrong. And we'll get to some of this in detail. So what are some of the limitations of LLMs? Like I started saying, it doesn't have access to private data sets. It has access to public data sets like or websites like Wikipedia and public forums and the rest. But when you talk about company data, it doesn't have access to your company policy documents and private documents for companies, for even for instance, Nigeria unindexed information, let's say about your tribe, anything that has not been published on the internet, that has not been published on a digital journal, or has not been collected, any data that has not been made public or accessible for training, it doesn't have access to that. So this limits LLMs, and so this creates a range of limitations. So first is the limited access to updated real-time information, and then secondly, it's which is the major reason why we need RAG, is hallucination. So aside the limitation to knowledge, given that LLM is basically it's a very advanced, sophisticated mathematical model that works with training. And for those of you who are familiar with the concept of training, you understand that we have accuracy, and even when model is training, when it's performing well, the trust is basically a mathematical competition, right? So there are sometimes that the chances of it getting wrong is very high, and so that's why you have to always refine your training, update, and use metrics to fine-tune your models to make it work fine. So those basic classical machine learning problems. So with LLMs, one of the major issues that affects the performance is hallucination. Hallucination basically is a situation whereby the LLM gives you wrong information with great confidence, right? So maybe you ask for who is the president of Nigeria, and tells you something like Buhari, which is outdated, and or it could even say something like Stevie Wonder, which is completely wrong. So hallucination can come in different forms, but hallucination is one of the major issues with LLMs, and this was about to break the trust for LLMs in real-world applications. Because imagine making a mistake in a medical record, or using AI in a medical setting, or in legal setting. As a matter of fact, hallucination has caused lawyers problems. I think there was a British lawyer last year who ran into trouble because he crafted a case, and all the references were generated, were fabricated. So these are real problems. So in order to solve this, we discovered that now outdated information we don't have access to. In order to make LLMs powerful, we need a way to be able to update information and also handle the hallucination, handle false information. Being able to, and one of the major ways to handle false or correct false information is citation, behavior reference, being able to back every information you generate with evidence, right? With evidence. This will make LLMs adoptable in research, in the medical field, in sensitive areas. So, and this is what gave birth to the need for a solution like RAG, right? So we'll get back to that. So and let me just go back to this particular diagram. So this is actually gotten from as you can see, level deep AI, because I actually felt this will actually communicate this concept very well. So in a traditional LLM, the way traditional LLM works is when you craft a prompt, it gets you, it's processed by the LLM, and then you get a response. Straightforward. So everything you're seeing in that's how it normally works. But with RAG, a RAG solution adds a new set to validate and increase trust in the data, basically adding context to the data. Or adding context for relevance in workspaces, and we'll see the use cases. So the first is, so we have a retrieval-augmented generation. Basically, in simple terms, is instead of allowing LLM, the traditional LLM, to generate content directly, you are now augmenting this generation. So you are adding additional context. Now, in basics, normally, you know that, okay, you know the concept of prompts. You know that in order to craft to be able to like get good results, you need to craft a good prompt. You need to add context. You need to add this. But the challenge has been that LLMs have context windows. They have limitations to how much text you can integrate into these various solutions. So how do we now still take care of that? And then if you are trying to fine-tune, model fine-tuning, retraining is also another method strategy that is used to improve the to add context, to update the information in LLMs. But if you have seen how the cost, or if you have ever tried to go through the cost of training an LLM model, you see that these are very expensive steps. You can, in order to fine-tuning a model is expensive, being from the data collection down to the training and even getting the accuracy, having the skilled personnel. So these are complex processes. So LLMs take RAG as a process that filters large chunks of data. So instead of, when you're not trying to add context, but you filter the kind of context you need. So when you have, let's say you have a library of books, you want to answer a particular question, let's say in biology, but you don't need to check computer science or check books on computer science or all these things. You can just filter out just the books in biology and use that as context to build a model. So that's basically how RAG works. It filters. You have a quick chunk of data. It stores this large chunk of data in a vector database or in a graph database, and then whenever you try to perform a search, it pulls this the relevant information and uses that as context in the prompt you are trying to feed the LLM, so that you are able to get more relevant, updated information. And we'll get to see that. So like I said, you can see everything in red. You see the retriever, you see the knowledge base, and then you see basically when you use the retriever, you first process the data into the retriever, and then once you are able to get, that's where your vectors, you embed, you generate embeddings, and then you build it in knowledge base, and then get relevant document, basically augment, and then anytime you perform a search, this actually is the relevant context is added, and then the LLM performs well with that. If it's confusing, don't be worried. We'll get into the details of that. So yes, so basically, like I said, so just to build on that, we have two steps, very basic steps in a RAG. The first step is the retrieval. So in order to, whenever you're trying to build a RAG solution, you first need to be able to index or understand or ingest all the relevant data that you need to be able to consider whenever you're trying to work with your LLM or your solution. And then that's where embedding comes. And then once you have that, then you move. Then anytime you now ask questions or interact with that LLM, it will pull into that data, that stored data, and filter and get the relevant information. So for instance, if you are worried, if you ask ChatGPT, let's say for instance, why are hotels expensive on weekends? ChatGPT will definitely give you an answer. But let's say you are building a solution for, let's say, a trip advisor, or let's say hotels.ng, and you want context with Nigerian data. You see, this answer will not be helpful to you because it's going to give a very generic answer. But if you want to build a RAG around this, you will need to first pull maybe information about hotel prices in Nigeria. And then once you have that data, when you ask that question, the RAG will now check whatever has happened in weekends in Nigerian hotels, let's say in Abuja, and then based on that information, it pulls Abuja or a Nigerian relevant data and answers your question based on that context. So it's not just answering about, because when you ask ChatGPT now, that question will just go around global. It has data about hotels from almost every part of the country or part of the world, and most likely Nigerian data might be missing because we're not really very good. We're not really yet there with indexing or having a lot of very structured data in a lot of things, just like it was mentioned at the beginning of this session. So this is an idea, and yes, so what is it? Basically, let's not to ramble about the various not to make noise too much. What are the key components of a RAG solution? So when you look at the first phase, like I mentioned, the first phase is to get the documents, and then when you get documents, so whether it's a web page, it could be a web page, it could be a video. To keep things simple, we're going to work with a PDF in this particular example, but it could be a web page, it could be a note, like it could be an image, it could be video, it could be audio, so many things. Also, whatever it is, you first get the document, then you chunk it. Now, the reason why you need chunking is because, like I said, even though large language models have context, have a limit to how much text, how much input they can take. I'm not make it too complicated, but just take it as a limit to input text. You cannot load a full book into your large language, into your text, into your prompt. If you even try using ChatGPT and you try to copy a full PDF and paste it in the chat, in the prompt, you will discover that you will get an error. Just if you can try it, you will see what I'm saying. So there's a limit to how much context or how much text you can put, and that's why we need chunking. So you need to chunk the data, large documents, so that you're able to still carry large amounts of information, but still being able to process them well. So when you chunk this data or chunk this text, you need to use an embedding model. So now we'll get to what an embedding is. Embedding to basically convert it into a structure that the large language model can understand, so that it can perform mathematical computations on it. And then you store that into the vector database. So once you have that, and then the second phase is now you have your data prepared. Anytime a query, you have a question, you make an interaction with the LLM or the solution, the query now embeds, and then you get it's compared with what is in the database. Your data is filtered, and then the context added to the LLM, and you get your results. So that being said, and yes, of course, this is an advanced for curious minds. We have this is a more sophisticated version of the model, just like the speakers at the beginning of the lesson. We were told that, okay, we have vector based, or we have embedded searches, semantic search based on we have semantic search basically, and then you have keyword based search. So this is like a very sophisticated model. But to keep things simple, you are hearing semantic search. What really is semantic search? Why do you need semantic search? So if you are to search for, let's say you have a job posting and you're trying to like search for let's say an AI engineer, jobs that have AI engineering in the job description. So now traditionally, for those of you who are familiar with software development, traditionally, in order to build this solution, you need to maybe use SQL or whatever. If you are using NoSQL, you basically map the text, try to get, okay, you lower case and just try to make word matching. So you look for exact words, like you look for exact AI engineering or AI engineer, and basically, so that's very limited because it matches letters or matches words, keywords, and all these things. That's very limited. Semantic search adds more sophistication by going beyond just the particular word you are searching for and going to search for words that mean similar. So for instance, you say AI engineer, data scientist is close. It's not the same word, but it's very close. Like you have data engineer, you have ML engineer. All these text or these job descriptions are similar, but they're not exactly AI engineer. So, but now in keyword search, you can easily miss these searches. But with semantic search allows you to be able to capture words that or context or let's say results that have similar meaning, even if it's not the same word. And this has applications in a lot of areas, right? And like I mentioned, so semantic search has applications in a lot of areas. This is the foundation of building smart chatbots right now. When you're talking about smart chatbots, whether you're talking about call center agents or you're talking about even search engines. Now, right now, if you use Google search, you usually see an AI search section that gives you like a summary of what you're trying to find. All these things, there's so many things that are powered by semantic search, which goes beyond just the ability to search or match exact keywords, but go after the meaning. And the reason why semantic search is possible is because of embeddings, right? So like I mentioned, high level, these are just very high level. There are so many contexts. Interactive knowledge, you can create internal tools that are powered based on internal database structures or company data, right? And if you're a lawyer, I don't know how many of you are familiar with I think is it a Pavilion, or there's this Nigerian app which allows lawyers to be able to like navigate and interact with legal cases, documents, search databases of large databases of cases of case files. So all these functionalities, you can do a lot in research. There are so many use cases for semantic search, and that's why RAG, the understanding of RAG is very important, because this will be whether it's chat, where you're trying to build a chatbot, a call center agent, you're trying to build a search engine, or research, or build, or even common agents. Like this is what's powering a lot of solutions. So semantic search, if you have questions, I know I might be going fast, but if you have questions, I'm just trying to break down some of these concepts for those of you who are not very technical. If you have questions, please drop them in the chat and we'll try to go over them. So yes, so what we have spoken about semantic search, we have gone over what a RAG is, and then now what is an embedding. So an embedding, now if you have a computer science background, even if you don't have a computer science background, you have elementary binary code. At least everyone who went to in your secondary school, you went through binary numbers and all, and you understand that the basics of computing of computer arithmetic is binary. Everything gets, at the end of the day, gets converted to binary numbers. So whether it's text, your voice, this video call we are on, every single thing is converted to binary numbers. So in other words, even LLMs, as powerful as they are, at the end of the day, before they are processed, everything gets boiled down to binary numbers. So this means numeric computation or mathematical computations are at the bedrock of every magical or powerful AI solution you are seeing. So in order to be able to process, whether it's image, video, or text, whatever data form you have, everything is converted first to a numeric form. Now, embedding, there are many types. In natural language processing, there are many ways to be able to process. There are many techniques that are used to convert text to numeric form. But embedding is so far the most successful strategy that's used to capture the meaning of your language. So embedding is the reason why when you put in something like man or king, it relates king to say something like king and emperor are similar, or ruler, like things like that. So embedding allows words, not just English, but even language, whether it's English, Chinese, allows the generation of mathematical models or mathematical structures from language text, giving the computer the ability to be able to map the intelligence or the understanding of human language in computing terms. So this is what powers solutions like semantic search and the rest. So semantic search, and in order to compute or get embeddings or generate embeddings, you need embedding models. Embedding models are mathematical models, and we'll not go into machine learning, deep learning models that will not go into. But this is what we are going to be using. So basically, an embedding model, the way it works is it takes the text data source. So whether it's the PDF we have now, it will take the PDF, the chunks of PDF, and then it will translate it into a vector. So a vector, of course, is a mathematical term, or at least those of you who are familiar with math, it's just a data structure in which we use to store the conversions that are generated from the embeddings. These are representations. So anytime you try to perform a search, these vectors are the representations that are now calculated or computed and then used to evaluate your what is relevant, perform similarity search, and then retrieve relevant information. So I hope I've not confused you. If you have questions, please feel free to drop them. When I get to the Q&A section, we'll go over that. So this is just a basic diagram, just quickly to go over it. See, in MongoDB, since we're using MongoDB, mind you, MongoDB is just one of many tools. We have, when we're talking about RAG, for this session, we're going over vector-based RAG. There are more sophisticated RAG alternatives that are very intelligent, like Graph, but they're more technical. and you can go into that, you can read into that later. But for this particular solution, this particular tutorial, we're going over the MongoDB, we're going over the vector based RAG, and you have a lot of solutions. MongoDB is just like one of them. You have Pinecone, you have so many other solutions. So just so you understand, you're not limited to MongoDB Atlas. This is just for reference. So yes, whenever, so basically the typical pipeline is when you ask a question, when you ask your LLM in a RAG solution, when you ask your LLM a question, it first converts that question into an embedding, and then you have a vector. That's a numerical representation of that question. Then it now checks the RAG that you have created, which also is an embedding, is a list of vectors, and then performs a similarity set using maybe cosine similarity set to find the nearest neighbors. This is kind of technical, but it just performs a math computation, and then it retrieves the values that score very high for that particular question. So basically mapping the items that are very similar, and when that is retrieved, you ever end up discovering that the question is being answered, or basically those particular retrieved texts are relevant to that question. So that's basically how it works, and they will be processing, will be going over that. So yes, like I mentioned, so vector databases, because we need to go over the practical session real quick. Vector database, of course, like I mentioned, MongoDB is this database that you're going to use to store the vector, and we are using vector because in this particular case, our RAG is storing or representing the data in vectors. Like I said, you have graphs, you have more sophisticated method techniques to use to present graph information, but that's beyond the scope of this class, just for those of you who are curious. So we are using MongoDB as our MongoDB Atlas as our vector database. So that's going to store our database. And yes, so we have come to at least, okay, so these are just extra. So just to reference that most of all these diagrams, none of these diagrams was created by me, and then all of them I just added links for you to be able to go over, for those of you who are curious, to go over these additional articles from Deep Learning AI and then also MongoDB Atlas if you are curious to read further about this. So now we have gone over the basics of RAG. We have gone over what you can do with RAG. We have gone over what the basic components, and it's now time for code labs. If you have questions before we get in, well, let me check. Let me. Okay, sorry. Okay, so let's go over the code lab, right? So basically, I'm going to be sharing a notebook. So for simplicity, to keep things simple, I decided to use a Colab notebook that you can copy or duplicate and follow this exercise. And I'll be pasting it in the chats. Let me just all right. Okay, so I can see a question. It says, for use cases, will you say Google Notebook LLM is a use case? Is a use case? Okay, yes. So I'll say, so I'll just quickly go over it. So yes, it works with most of your solutions you're working, whether it's Google Notebook LLM and most of these, even what I call it, even Perplexity, like many solutions, so long as most of these LLM solutions that are not just using raw ChatGPT, DeepSeek, and all this, if they are adding context, most of this context is processed is using a RAG solution. So it could be, the use case could be different, whether it's coding, even your coding solutions like Windsurf and the rest. Most of these extensions with VS Code that are able to help you, Copilot and the rest, the whole reason they are able to work is because they are powered by some of the solutions, by some variants of RAG. And yes, so let's I'm going to share I'm going to share this notebook, right? So this notebook, I shared it in the chat for those of you who are going to follow through. You can, it's just simple, it's just a simple demo or an example that will walk you through the steps, very basic steps of how to build with how to build a RAG, a simple RAG with what's the name, with MongoDB Atlas. So I will go over it. So let me share my screen for this. Let me share my screen. Okay. Okay, so I hope you can see my screen. I hope you can see my screen. So yes, so basically, like I said, to keep, I don't want to have so much scripts, too many Python scripts and confuse those who are not technical. So this is going to just be a straight example, and I'll explain I'll explain the code as we go through. So for context, we'll be working with this example. We're working with this. This is a PDF we'll be working with. I'll paste this PDF. Sorry. Just give me a minute. So you also have access to, I'm pasting this PDF in. All right. All right. So I'm pasting this PDF in chat so that you also have access to it, and I'll also share that. So basically, what the content of this PDF? This is basically a MongoDB quarterly report. It's just an example of a document. Now, when you're building, like I mentioned, your RAG could build from, could be having data from sourced from websites, from a complete, in a real world RAG is actually a combination of a lot of complex and or multiple sources, from markdowns, code files, CSV files, Excel sheets, like PDFs, PowerPoint presentations, voice notes, videos, and the rest. So there are so many different points. But to keep this simple, we are using, for this experiment, we are using just a single file, and this is basically a MongoDB reports, financial reports with a lot of text, and then also some tables, some financial tables, just to give you an idea. And yes, so this is this is what we're working with. So let me just go over the basics of what we'll be doing. So here first things first, of course, we'll be installing the libraries. We'll be using LangChain. So LangChain is a library, is a framework that has a lot of helpful utility functions that allows you to be able to integrate, build AI agents, machine learning, AI solutions, connect to various LLM solutions with ease, right? So we'll be using the LangChain libraries. We'll be using MongoDB to PyMongoDB to connect to MongoDB database, and then we'll be using Voyage AI. Now, Voyage AI is an embedding model by MongoDB. Now, and the reason why we're using it is because it's not just an embedding model, it's an embedding model and a re-ranking model. Now, I didn't explain re-ranker, but I'll just give you a very simple explanation for a re-ranker. Now, when you retrieve data, so when you are working with a RAG and you ask a question, and the question brings, let's say, you go into your database, and then the data now for the LLM now finds out, you find out that, okay, from your vector database, about 20 documents are similar to this question. Now, you don't know the order. The problem is that the LLMs sometimes suffer with arranging when that particular vector, even though it gets you the relationship, it's the order in which you sort what is most relevant. Sometimes it's difficult, and that is why you need an extra layer. So if you go back to the initial document I shared with you, this particular slide. This, yes. So So on this particular, you can see that you have a ranker. So basically what the ranker does is sorting the results, the retrieved results, so that you have the most relevant first and then the least relevant last. So there are many strategies, but Voyage AI is a very good option for the ranking. So you can use, there are many models. You can even use the normal chat or open AI models to perform this. But Voyage regard worked on his model that actually solves this problem. So I'm working with, we'll be using this solution. So we'll be using this AI model to build in this experiment. Just I'm sorry. So yes. So if you have, first is first, we'll be going over. So just give me a minute. I'm trying to. I have an emergency. I need to just sort. Yeah. All right. Yes. So these are the steps we are going to take. The first step would be to of course, if you don't have a MongoDB account, you create an account, and then let me share my full screen. All right. So I hope you can see my screen. I hope you can see my screen. So sorry. All right. So yes. So now, so the first step would be to visit the MongoDB data. Will I say the MongoDB platform? And if you have not if you don't have an account, you sign up. But I will simply log in to keep this simple. Just I'll log in, just keep this simple. And so now after logging in, okay. So we log in. If you don't have an account, you sign up. You can easily sign up, and then once we log in, so we are using the Atlas. Now we are using MongoDB Atlas. Atlas is the version of MongoDB that is optimized for this kind of tasks. Now, MongoDB, of course, it's an open source solution. If you want to configure that locally, you can or if you are trying to configure this locally, you can actually do this. You don't have to use the website. This is just the hosted version for those who want to use, who don't want to deal with server configurations. But if you want to set up locally, you can actually do this. You can actually set up everything locally without having to pay. So that's one very great use case with MongoDB, with Atlas. You can actually set up locally and configure without having to pay if you want to use the online version. So yes, so even though I have this set up, I'm going to delete this too. I will need to delete this, so I'll walk through this example together. So I'm going to, let me just delete this. While I do this, those who are trying to follow should please just create the account and let me know if you are stuck so that I don't rush. So it should take some time for us to get to the cluster, because with MongoDB Atlas, you have a free your first cluster. You have the option to be able to create a the first cluster free, and we'll be using that, so you don't have to worry about having to pay. Although, in order to follow the tutorial fully, even though it's a free plan, you might need to, if you're having an account for the first time, you might need to put in your credit, your card, a card detail for you to have access to Voyage, to Voyage AI, but you won't be charged. You have free for every for you. Voyage AI is free for requests to the DB that are 200 requests per minute. Anything lower than 200 requests per minute is free, so you don't have to worry. But you need, for some reason, I tried today and I saw that the update required you to have actually put in your card. So you can just put in a card which maybe with just a dummy card, or a card that doesn't really have much in it. So just to get through the process. So I have a card, have a card attached, but I'm not charged. It's free. So once you have signed in, you head over to, on the left side on your sidebar, you go to the search and vector search. When you click this, you create, initially the process was actually more tedious than this, but this is now quite straightforward. So you head over to the search and vector search tab option, and then you click create tab, right? So you create tab, and you create the tab, and yes, this is where you have the option to select the service you want to work with. You have paid service, you have different server configurations, but you can see that we have a free server. So you have the free, and this is what we'll be using for this tutorial, a free server option. And you have, although you, of course, you have 300, you have 500, roughly 500 MB RAM and all this. So in a real world, in a very practical, real production setting, this might not be very depending on the work you're trying to do. If it's not a personal project or a very in-house project, this might not be very efficient, but this is going to be sufficient for our project. So once you have this, you select the option, select the free option, and then you come here. You can rename, you can leave it as this, but I like to rename my cluster. So I'll call this RAG. I call this RAG, and then you can select any of the cloud providers, because behind the scenes, MongoDB hosts this on a cloud service, or that's either AWS. So I'm just going to keep things simple and leave it here. So having done that, you can now go ahead and create your deployment. So once you create this deployment, we have our free cluster being created. And yes, so this is where it's important for you to pick this, get this connection string. So this is what you will use to connect your database. So in this particular use case, when you select the, sorry, I think we need to, just so that I explain what we are doing. So under the driver section, we are going to we have created the cluster. We will now try to connect this cluster to our application. And so that's why I'm using this driver section. So if you are following with this tutorial, you click the driver section, and then you have the option to connect to different programming languages. But in this case, we just need Python, and we don't really need the Python code. We just need to copy this particular string. So if you look at this string, you just basically have the username. You have the username. You replace this section with the username. You replace this section with the password. So I am going to keep things simple. You keep the password, and I know you'll be asking, okay, how can you generate this password? I'm going to show you that right now. I'm going to show that to you shortly. Let me just create a tab here and do this. I'll be deleting this after this experiment. So let me just create this. So once you have copied this URL, make sure that you have copied this URI, because you will need it to connect to the database, right? So once you have copied this, then you can head over to that's the next step. if we go back to our settings, the next step would be to go to the network, right? So we have, first things first, you go to, what's happening? So you go to database and network. Under security, you go to database and networks, network access. And of course, here you can create a database user. And then this user will now have the password that you will use to connect to the database. So once you create a user, I've already created my credentials. So you can go ahead and create those credentials, and then you replace that here. You replace that here with password. You replace that with the username and the password. This will allow you to connect to the cluster you just created. So once you have that, we're ready. The next thing you will do is to go to network access. So under database and networks, you go to network access and you go under IP access. Now, this is for security reasons. You need to be able to access the database. So for security reasons, and to be not so that you're not blocked by the firewall or blocked by configuration by MongoDB, you need to have the MongoDB disables connection or access to the database by default. So even if you have the right keys, you will not be able to connect to the database. So you need to create an IP, and then we'll use this for this configuration. We'll use this configuration. We'll just keep it simple. So we're going to use 0.0.0.0. This IP. So basically, we're just trying to say everybody should be able to, any IP should be able to access it. This is not good practice in production, but we need to just keep things simple. We're not going over networking concepts here. Just simply paste this in this and create confirm. I already have that for the sake of this tutorial, and the reason is because if we are using Colab, right? If we are using Colab, so Colab will require access. Will have an IP that will send instructions to the MongoDB, and that changes with time since you are using Colab, and that's not your environment. So we're just keeping it simple so that every time you run with Colab, you are able to have access to this. And yes, for those of you who are also following, you go over to the billing tab. I won't click that here. So, but you go over to the billing tab, and then you add a card. The billing tab, you can find it here. You can just add a card. And once you add your card, I think a Nigerian card should be able to work since we don't have restrictions. Since some of these restrictions have been lifted. So, once you add this card, you will be able to access. You won't be charged. Remember, you might just be charged $1 just to test that the card actually works, and then after that, it will be reversed, and then you can have access to the environment. So once you have done this, the last thing we need to do here is to head over to services. Under services, you go under AI models, right? You go under AI models. Under AI models, you will need to create an API key. So this API key is for Voyage AI, so that you're able to have the access to MongoDB's embedding and re-ranker model. So this is very important to have this. So once you create this, you copy the API key, and we'll use this. So once you copy that API key, we are done and we are ready to navigate our environment. So having said that, so now we have completed all these phases, and the last step, of course, is to go over to OpenAI, and where you use pretty straightforward. Copy OpenAI, log in, and generate an API key if you don't have one. And we'll be using, now you must not use OpenAI, but for this tutorial, I use OpenAI. You can use Gemini, you can use any other tool you need. You just need access to a large language model via API that you would use to pre-process and post-process the solution. They're not limited to OpenAI. So, but if you want to use OpenAI, you can go over to OpenAI, the platform.openai.com, and then you head over to API keys, and you will be able to create that. For privacy reasons, I don't want to show that screen because I have my keys there as well. So once you have completed this, then the next thing to do would be to use, because now this is this is the same thing as creating an environment, as creating a config, or let's say an environment variable just for privacy. It's Colab has a feature that allows you to be able to add secret keys, so that I'm not just pasting my password publicly for you to see here, right? So that's the only reason I'm using this. If you have a developer, you have worked with .env files or config or so text files, you know how to load securely load API keys. That's basically what we're doing here. So I have a number of keys here, but I only need 3 for this particular tutorial, which is the OpenAI key, the MongoDB URI, and then the Voyage AI key. So I already have the Voyage AI key. I have my own MongoDB. Of course, I'm not going to show you, but I need to modify my since I deleted the old database, I need to modify my MongoDB URL just for the sake of this tutorial. So I'm going to simply copy this. I'm going to just copy this, and in your own case, since you have created the database, the username, the database, and the database user, and then the user password, you simply just replace everything here. So everything before the column, between the slash and the column, you put in the username, and then everything after the column and the @ you put in the all right. I think I have it. Okay. You have a question? I just got. Okay, it's not a question. I got a notification. I thought someone was asking a question. So that since you don't have a question, we can proceed. Reconnect, and then let me reconnect. So like I was saying, so once you have replaced this this string, you can copy this URI and of course put it securely so that you have access to your data. So I'm going to simply replace. I'm going to simply replace. All right, so I've replaced my my keys, and we now have everything should be functional now. So now we can now go ahead and run this code. So if you are with me, or if you are stuck, please feel free to stop me. Otherwise, we proceed. So now, having done that, the first step would be to now run this library. So this is equivalent to running a request.txt, that's pip install request.txt on Python. But since we are using Google Colabs, we are just trying to temporarily use this cell to run everything. So we're installing the PyMongoDB, the PyMongo library, the Voyage AI, the OpenAI, LangChain text splitter, and community PDF, PyPDF, of course. So once we run this, we run this file, it's going to install the libraries, and yes, we should have, yes, so we have the library installed. The next is, of course, so the only reason why we need this particular line, we need to import this, is because we are working with Colab. If you are using a .env file to load your secret keys, you don't need this line. You can just simply see that this is the traditional environment variable. We're just loading the variables here, and we're just trying to find it. So if you want, if you don't want to go through that process, you can easily just paste your keys here. But I'm not pasting my keys here because I'm sharing my screen and you are seeing what I'm doing. So but you can paste your screen. You can just paste the string here, and then you will have access to it in this environment variables, which we'll be using. So since I have all that, I can just run this cell. And yes, so having done that, we are very close to, we are soon going to be done. The first process we will be doing will be to ingest the data. So in our retrieval, the first step of the retrieval augmented generation is preparing the data. So we are going to be loading the data, breaking them into chunks, and then we will now process that. We will now generate embeddings for those chunks, and then we'll store those embeddings. So, and what we need, we need libraries. We need, of course, this. We need this. The OS library for obvious reasons. We are working with the environment variables, and then we need Voyage AI. So Voyage AI, the Voyage AI model. For those of you who are not familiar, I'll just copy this link and paste it in the chat as well. All right. Okay. Am I pasting to the right section? I hope I hope you can see it. So I'm pasting this so that you can see. And the major reason I'm posting is, so of course it gives you the idea of the pricing, but it also shows you the available models. And you can see something interesting here. You can see that this is slightly better than using OpenAI to run your embeddings, or to run because this has more context. You can see that, for instance, you have the Voyage 3 model, a large model. You have the light. You have, and each of these has their pricing. But you can see Voyage code. You can see that definitely means that this particular embedding model is optimized generation, or code interaction, code embeddings. And then you can see that this one is optimized for language. So if you are having to do with RAGs that require multiple languages, maybe Chinese, different Arabic, different languages, you can see that instead of using a general model, this one might provide more. And if you are trying to do it, if the RAG you are building is related to finance, you can see you have an embedding optimized for data. You can see one and optimized for law and the rest. So there are more models. So that's why I'm sharing this with you, so that you have context. Of course, because beyond just building a basic RAG solution, you should be able to think about how this applies in the real world. So, having said that, so in this case, we are using a Voyage Finance model, of course, because the PDF we are working with, like I shared earlier, is a financial report. So that makes some sense. So of course, this is the library. We are creating an object instance of the library, and this is the function that will generate embeddings for each chunk of data we have. And simply what we are doing here is we are the next step is to load the data, and this is pretty straightforward for this particular case because we just have a single file. If we had multiple PDFs, we could easily use a for loop to build, or there are libraries like unstructured.io. In this particular case, to keep things simple, I did not bother processing the metadata or ingesting or doing all those things. I just kept it simple. But in a real world setting, when you're trying to handle citations, you just don't want to create chunks, but you also want to have map the sources of those chunks to be able to have, so at any time you are giving an answer, you are also giving reference to the link to the source, so that when you give an answer to something, you can say, okay, this is found on this book, on this particular document page, this, or this particular website page, this, so it is verifiable. Now this helps you to be able to build solutions like law, medical, and all these things that can be trusted, because people can easily verify the information. So, but for this case, we're keeping things simple, and we are not manipulating any metadata. If you want to do that, you can use libraries like unstructured.io. It's a Python library that allows you to be able to do that. So, having said that, the next step, of course, so we are just simply using this PDF, like the PDF loader library, and this PDF, the PDF URL, public PDF URL is loaded. That will be downloaded and then downloaded. So basically, what we are having here is we are having a chunk size of 400. We're trying to say that we have tokens of 400. It will count the words. Basically, tokens. Just keep it simple. The words in the document, and then over 400. This is so maybe the first 400 words will be the first chunk. The next 400 will be like that. And to add context, we have an overlap of 20. So basically by overlap, we mean that when it counts the first 400, so from 0 to 400 in the first chunk, the second chunk will not start from 401 to 800. It will start from, let's say, 380 and overlap, so that because LLMs work with context, so that the LLM is able to also use the overlapping to understand that these are connected. These documents or these chunks are connected. So it's very important too, and that's what basically these variables are for. And then we generate the basically at the end of this. By the time we run this, if we run this, we have been able to split our documents, and we have, if we decide to print, let me just use this. If we run this, you can see that this has actually also already even generated a metadata. You can see that if you look at this title, you can see this is the title. This is the PDF we are working with. You can see the title. You can see the source, the PDF link. You can see it has automatically generated the pages, the total number of pages. You can see that already automatically added the metadata for this particular value, and you can see that. Just to correct what I said, when I said chunk, the chunk size is, in this case, is character length, not token length. So you can see the size. You can see this size, and you can see that this is where it's ending, right? It's a 400 character token. You can make this longer, but we're keeping this simple for this particular example. So that's how it's chunking. That's how it's chunking. If we go to the next, just to add more content, let me just show you the next in this array. If I copy this and I paste it, and let's say I work on second, I just want to show you the overlap. So if you look at this very well, you can see that when you look at this particular content, you can see the continuation. This is a continuation of the document we have. So when you look at the actual PDF link I shared with you, you can see that this is a continuation of the document we have, and that's how it continues. This chunks this document. If we look at the length, just lastly, if I decide to print this length, I will see how many chunks we have. We have 88 chunks. So we have 88 chunks, and this is pretty straightforward. So now, having said that, so that means these embeddings, now we have, remember, this was the function we had for embeddings. And what I will basically do, we are structuring this document for our LLM, for our database. This is a list. This is basically a list comprehension that is saying that we want you to, this list is going to be made up of dictionaries. And in this dictionary, we just need two attributes. First is the raw text, and then the next is the embedding of that text. So that is basically what we are saying. We're not storing any additional data. We're just keeping it simple. This embedding, just so you're not confused, is simply this function that we have here, get embedding that we have here. And when we run this, it executes for some time, and then we will have our embeddings generated. If I decide to print the first, just because I want you to understand. I hope my time is not up. Okay. I think I need to hurry up. So yes, so if I print the first value, you can see that you have a vector. So this not much, it's not rocket science. You can see the vector, the translated, the numeric version. We mentioned that our vector embeddings is a pool of numbers that we use. So every text, you can see that for every embedding you will have this long list vector of values. This is just one of the embeddings. We can see the results here. So once we have those embeddings, we now store this to the database. So, and of course, yes, this is basically the name of our RAG. What you have here, if you left your cluster, if you did not rename your cluster when you were creating it, if you left at cluster 0, then here this RAG will be cluster 0. This is just basically the name of your database and nothing more. So, and then this collection is the name of the table. So you can name this, it can be any name, but basically I'm naming this semantic search table, just to keep things simple. And then of course that the URI, this is what gives us access to the database. So once we do this, we'll be running this to load to feed our database with the embeddings we have generated. And right now we have been able to store them. So the next thing is to be able to use this, and I'll keep this very simple. Basically, what we're trying to do here is we are creating a search index. This is for those of you who are curious, you can go further and read what a search index is. Basically, this search index is what's going to help us to be able to generate to perform the semantic search. So this is the definition for our search index. And the type of the index we're trying to create is a vector with dimensions 1024, and then you can see, and then of course you can see that basically we are trying to see what is it going to use to calculate this similarity is cosine similarity. This is cosine. This is an algorithm that has been simplified for our use behind the scene. This is performing cosine similarity. So it means that anytime you're trying to perform a similarity search, it's going to use cosine to perform cosine similarity to perform the distance between each vector and see and retrieve which ones are close. This for those of you who are curious, you can go and read into how cosine similarity helps RAG solutions to function. And of course, very simple, very basic thing. So this is basically what we're doing here, running on this, and we are creating this particular cell. So once we run this, we have to run for some time, and when it's done running, you will get an email that notifies you that a vector index has been generated. So you will get an email on your MongoDB account that notifies you that this has been successful. You can actually do this via code, or you can do it from the UI. So in the past, I've done it in UI, but this time I'm doing it from the code just to keep this simple because we don't really have time. And yeah, so you can do this from the UI. You can simply copy this. You can copy this config and paste it in the UI. There's a section on the UI that allows you to do that. So once you have done this, of course, we have been able to generate our vector or our database now, right? So the next is now a function that will allow us to perform our search. So now we have created our vector, we have our embeddings, we have our RAG solution set. And if just to help you, I want to work visually, so you see what's happening. You can see if we browse our collections here, just to see that I'm not just making it's not just gibberish. If you go to the table here, this network is. I wanted to show you on the database that we actually have generated our RAG and that the data has actually been loaded to the database. So once we have this, so this function basically takes in a query, and query is basically the question you are asking. So when it takes this query question, you see that the first step is it generates a vector embedding for that particular question. And then once it generates that vector embedding, it now performs a search on the RAG you have done. So once you have generated the embedding, the vector, those numeric values are now compared with the database. And of course, all these limits, in this particular case, you are saying you are limiting to just five results and the rest. So just keeping it simple. Of course, in the real world setting, it will be more than that, but we're keeping it simple here. And that's basically what it's doing. So all this function is doing is trying to get the result. So if you look at this particular issue now, this is just giving you basically we are trying to just see how a sample of how this works. So you can see that this, when you perform a result, this is what is returned. It returns all the text. When you see, for instance, if you search for a query AI technology, it returns all the chunks that are relevant to that. So you can see that the first text, this is the text. MongoDB continues to expand to its AI ecosystem .. You can see you can see AI is inside, even though AI is not like keyword search. It's not searching for AI technology as an exact word, and that's what makes semantic search very beautiful, because you have AI technology, but you can see AI ecosystem is related to AI solutions. You can see you have artificial intelligence. This is not a word for word search. It understands that artificial intelligence has similarity with AI technology. So you can see that in every single chunk of text that was retrieved, you have something that is related to AI in this particular chunk. That's what makes it beautiful, but this is still in raw form. So now that we are seeing that the semantic search is retrieving relevant data, is pulling all this, what can we do to be able to generate responses that are generate relevant response and feed it into our LLM? So Now we now import, we now use OpenAI. Now we open OpenAI, and then the question we're trying to ask, the sample question we will try to test here is, but you can now change to be curious. If you want to test this, you can change this question to any question of your choice, right? You can change this to any question of your choice, and whatever question you ask here, the same process will be performed. You will get the embedding, and if let me run this here, and then you can see that once we generate this particular chunk of text, basically what this line does is it goes through all the chunks of text that was retrieved, and it joins them into one continuous statement, right? It joins them into one continuous statement. So that's basically what it's doing here. And then when you look at this, you can see the full chunk of text. This text is this is what now you can now use as relevant context for your LLM. So you see that even though this is a PDF, if you had a large chunk, let's say millions of PDFs or thousands of PDFs, it will still pull relevant chunk. Instead of you spending so much money loading the whole context, which depreciates the quality of the LLM's results and also relevance. This solution now, you can easily put context, and then you get the relevant sections in your documents that you can use to provide context to your prompts for information for the LLM. So now basically, this takes us to the augmentation. So this is the augmentation. So you can look at this prompt. You can see that this is a simple prompt that says using the pieces of context in to the answer. So use the pieces of context to answer the question at the end. And basically what we're putting is, this is the context. This context string is this text we have here, and the question is simply this question we have here. And once you feed this into ChatGPT, you will have the relevant response that you need, and ChatGPT will use that to give you a relevant answer. And if you look at this, this is not giving very readable. Let me copy this into a text field, and if you paste this here, you can see that what we can see what we have. So you can see it says it gives you an answer. The ChatGPT. Okay. Am I the only one here? Okay, all right. Okay, I'm still here. Okay, all right. So yes, basically you can see that it has answered. So this is ChatGPT. This is now like ChatGPT responding to your question, but unlike using a typical ChatGPT solution, which has no context of the data, the private data you have, this allows you to be able to add context, and now this can answer your question. So imagine this with law firm, with law data, with legal data or medical data or with other records. You can provide context. If you are building a chatbot for a company and you want, let's say you have a customer care support system that is able to respond to customers about how your business operates, you can build a RAG solution. You can put all your policy document information about your pricing, information about your services, and use all those data as context and build your LLM with it, or build your chatbot with it. And this RAG will power your solution and help you to get a lot done. This can be improved to something more sophisticated, but this is the end of this particular tutorial, and it will now be time for questions. If you have questions, and yes, if you have, sorry, my lights got up and I can't leave the seats to go and set up my inverter. So, but yes, this is I've come to the end of the tutorial. I hope you all were with me, and let me see. I don't see any questions.
Yeah, I think you've answered most of us. So the question that you had earlier, you must have spoken to it when Victoria said, for use cases, would you say Google Notebook LLM is a use case or uses some features of RAG?
Okay, yes. Okay, yes. Yes, thank you. I think yes. I responded to that.
Yes, so, yes. Already. Yes, you did. Thank you so much, Samuel. Bola, Victor, Engineer Lowell, it's time to take your questions. If you have a question, you can raise your hand. You also have the chance, you can double check now. I've given everybody the ability to unmute their mic and speak. Well, thank you so much, Samuel. Me myself, I am learning new things from this session. I have to go back to YouTube to actually rewatch because my internet was keeping at some point. Thank you so much, Samuel. If there are no other new questions other than the one that has been asked on the chat room, I don't know. I'm trying to authorize mic permission for people, but it appears that they are unable to use it still. But whatever it is, you can still write to us. You can write to us at labs@techlytics.ai. Let me just put that in the chat room. If you have a question or you want to revisit this video or video learning, it's on YouTube. I'll look up for the YouTube link and also I'll put it in the link here or in the chat room here. Thank you so much. I really appreciate your time. So I don't keep you waiting for a longer time on the call, Samuel. Thank you. I'm going to bring the webinar to a close. I'm going to share right after I share the link in the chat room now. I'm going to share the link in I put the so this is the YouTube link, and I put it in and this is the email to write to if you have any question whatsoever. All right, thank you, everyone. Enjoy the rest of your evening. Thank you so much, Samuel. Ian will be in touch with you. Thank you. Enjoy the rest of your evening, guys.
All right, thank
you.
Good
night.
Yes,
bye.